Okay, this is going to be the Unit 5 test review. So we're going to start with 1A. So this one says solve the system of equations. And if you can see, this one is set up for elimination because the x's are lined up together, the y's are lined up together, the equal signs are lined up, and then the numbers are lined up. So the first thing we want to look for is if we have anything that will cancel out. So right here, if we look, the x's are both the same number, except one is positive and the other is a negative. So since one is positive and the other is negative, when you add those together, they would equal 0, which is what we wanted. So since we have opposites here, we're going to add these two equations together. So negative 4x plus 4x is 0. Negative 2y plus 8y is positive 6y. Negative 12 plus negative 24 is negative 36. And then this 0 here doesn't matter because 0 plus 6y is 6y. So I'm just going to cross it out. Now to get rid of this 6, I divide by 6. So y would equal negative 6 here. So that is our first. We have y. Now we're going to plug it back into either one of these. So I'm going to take this top one here. If you pick the bottom one, you'll get the same answer. So the top one was negative 4x minus 2y is negative 12. Now we already know what y is, so I'm just going to solve for x. And the way I do that is I replace y in this equation with negative 6. So negative 4x minus 2 times negative 6 equals negative 12. When we solve this, we get negative 4x. Negative 2 times negative 6 is positive 12. And that equals negative 12. Then I can subtract 12 on both sides. So we end up with negative 4x equals negative 24. Then to solve for x, I divide by a negative 4. So x equals positive 6. So the final step here, we need to write this as an ordered pair. So the x will come first, it'll be 6. And then our y is negative 6. So 6, negative 6 is the answer. Now if we look at 1b, this one is also elimination because the x's, y's, equal signs, and numbers are lined up. And again, we're looking for things that are opposites that will cancel out. So 5 and 4, those are not opposites. But negative 6x and 6x, those are the same number, but one is positive and the other is negative. So I'll add these together. Negative 6x plus 6x is 0 because those canceled out. It doesn't always have to be the x's that cancel out though. It can be the y's. Then 5y plus 4y is 9y. 1 plus negative 10 is negative 9. Again, the 0 doesn't matter. So to get rid of this 9, we divide by a 9. So y equals negative 1. Now we just have to plug it back in to figure out what x would equal. So this time I'm going to take the second equation. Again, it doesn't matter which one you pick. So I'll have 6x plus 4y is negative 10. But this time I'll replace y with negative 1. So 6x plus 4 times negative 1 is negative 10. 6x, 4 times negative 1 is negative 4. To get rid of this 4, we're going to add 4 to both sides. So we get 6x equals negative 6. Then to solve for x, divide by 6 on both sides. So x equals negative 1. And our last step, write it as an ordered pair. So negative 1 is our answer. So the x comes first, then the y. So those are both elimination. Now for 2, we're going to move on to substitution. So on this first one, we have y equals 6x minus 11. And on this bottom equation, we have negative 2x minus 3y equals negative 7. So we know this is substitution because we have one of these variables by itself. So y equals here, that tells us it is substitution. So we're going to box this in because that is the variable that's by itself, what it equals. Since this is y equals, we're also going to box the y in this bottom equation. So what this box is going to do is just going to tell us we're going to replace this y with everything that's boxed up here. So our equation will become negative 2x minus 3. And then this y is boxed, so we're going to replace it with 6x minus 11. And that will equal negative 7. Now we're just going to solve this equation here for x. So my first step is always to distribute. So negative 2x, negative 3 times positive 6x is negative 18x. Negative 3 times negative 11 is positive 33. And this will equal negative 7. So then I combine like terms. We have negative 2x and negative 18x. So when you add those together, you get negative 20x plus 33 equals negative 7. Now we want to get our variable by itself. So first I'll get rid of this 33 by subtracting 33. So those cancel out and we have negative 20x equals negative 40. And our last step here, we divide by a negative 20. So x equals positive 2. Now just like before, we're going to have to plug this back into one of these equations to solve for y. So I'm going to pick the one that's y equals because it's easier. So I have y equals 6x minus 11. And just like we did in those two problems up there, we're going to replace the x with whatever we found it equaled. So it'll be y equals 6. Then I'll replace it with this 2. So 6 times 2 minus 11. So y equals 12 minus 11, which means y equals 1. So our final answer here is 2, 1. Now 2b is going to be the same thing. This one is set up for substitution because it's y equals up top, and then we have a standard form equation on the bottom. So I like to box it in because that's the one that y equals, so it equals all of this. Since it's y equals, I box in the y here. If this was x equals, I would box in the x. And then we just replace or substitute. So I have negative 3x minus 2, but I replace that y with all of this. So I replace it with 5x minus 7. And that equals negative 12. Then we solve, so I distribute. And we get negative 3x. Negative 2 times 5x is negative 10x. Negative 2 times negative 7 is positive 14. And that equals negative 12. Then we combine our like terms, so negative 3x minus 10x is negative 13x plus 14 equals negative 12. Then we have to get rid of this positive 14, so I subtract 14 from both sides. So negative 13x equals negative 26. Then we divide by negative 13. So x equals positive 2. Now we need to figure out what y equals. So I'm going to take this y equals equation. So it's y equals 5x minus 7. And I'm going to replace x with whatever x equals. So x equals 2. So it's y equals 5 times 2 minus 7. So 5 times 2 equals 10, minus 7. So y would equal 3 here. So our answer would be 2, 3. Okay, now we're going to move on to 3, which is graphing, maybe. So on 3a, it gives us these two equations. We have y equals 3x minus 4 and y equals negative 1/2 x plus 3. So what we're going to do is we're going to graph both of these separately. So I'm going to start with this one right here. I'll do it in red. So we have y equals 3x minus 4. So that means our y-intercept for this one is a negative 4, so that's where I'm going to start. And then my slope is 3 over 1. So remember, if there's not a number underneath, it's a 1. And that means I go up 3, so 1, 2, 3, right 1. And I keep doing that till I reach the end of my graph. So up 3, right 1. Up 3, right 1. And once I have that, just connect it with a line. Now our next one, I'm going to do in green. So this one, our intercept is at positive 3, so that's where I'm going to start. And my slope is negative 1/2, which means I go down 1, right 2. Down 1, right 2. I could also go up 1, left 2. So now that it fills my whole graph, I'm just going to draw the line. Now it wants the solution here, so it's an x and a y value. So what we're going to look for is where these two lines meet. So the intersection is our solution. So right there, what I have circled is our solution. And if we look, the x value, that's what we're going to put first in our ordered pair. So the x value, that point is at 2. So our x value is 2. And then our y value comes second. That one is also at 2. So our solution here is 2, 2. Now 3a is going to be the same thing. So for this one, my intercept is a negative 3, so that's where I'm going to start. And my slope is 1 over 3, so up 1, right 3. Or down 1, left 3. Then just connect it with the line. Okay, my next line is negative x plus 1, so my intercept is at positive 1. Now negative x is the same thing as negative 1 over 1, which means down 1, right 1. Down 1, right 1. You just keep going. Or you could go up 1, left 1. And once you have all your points, connect it with your line. So now if we look, the point that they meet is going to be right here. So we need an ordered pair. If we look, our x value is a 3, and our y value at the intersection is a negative 2. So 3, negative 2 is our point here. That is our solution. Okay. Now to page 2 and number 4. So 4 is set up like elimination because the x's line up, the y's line up, and the numbers line up. And this one was actually changed. So hold on. This is not the right one that should be in your review. because that one is actually kind of hard to solve. So give me just a second, I'll write the correct one we have. We're going to come back to 4a in just a second. So we're going to go to 4b first now. So this one is set up for elimination. And with elimination, we're looking for things that can cancel out. So we have negative 3x and 12x, so those don't cancel. And y and negative 4y, so those don't cancel either. So what we're going to have to do is we're going to have to figure out what we can multiply one of these equations by to make it cancel. So if we look here, we can either pick x's or y's. So I'm going to go with x's just because that's what I have right now. And if you did y's, you're going to get the same answer in the end. So we want to cancel out a 12x, which means we want this negative 3x to end up as a negative 12x. So I have to think, what could I multiply negative 3 by to give me negative 12? Well, the answer to that is a 4. Because 4 times negative 3 would give me that negative 12. That cancels out the positive 12. So I'm going to multiply each one of these things by a positive 4. And that's going to give me 4 times negative 3 is negative 12x. 4 times, this is a 1, so 4 times 1 is plus 4y. Then don't forget to multiply this last number here. So 4 times negative 9 is negative 36. Then we aren't going to change this bottom equation, so I'm going to rewrite it the exact same. So 12x minus 4y equals 24. Okay, so now notice we have what we wanted. These two are going to cancel out. So now that these cancel out, we add them together. Negative 12x plus 12x is 0. 4y plus negative 4y is 0. And negative 36 plus 24 will be negative 12. Notice that both of our variables canceled out here, so we're going to have 0 equals negative 12. So since 0 equals negative 12, and the variables are all gone, we know this is not a true statement. So if these two numbers are different, and all of your variables are gone, the answer will be no solution. Now I still don't know what the correct answer or the correct problem is for 4a, so I'm going to make one up that's going to help you. This will not be the same one that's on your paper, but that's okay. This is just another extra practice. So we're going to have 3x plus 6y equals 10, and 9x plus 18y equals 30. So for this problem, again, we're looking for something to cancel out, but notice nothing does here. So this time I'm going to focus on the y's instead of the x's. Like I said, you can pick whichever one looks easier to you. So I want to cancel out this positive 18y, which means I need this top one to be a negative 18y. So I think, what can I multiply 6 by to get negative 18? And the answer is negative 3. So when I multiply this one, it becomes negative 9x. Negative 3 times positive 6 is negative 18. Y. Negative 3 times 10 is negative 30. Again, don't forget to multiply this last number as well. Then I didn't change the bottom one, so I'm going to leave it the same. And since negative 18 and positive 18 are opposites, we can go ahead and add these equations together. So negative 9x plus 9x is 0. Negative 18y plus 18y is 0. Negative 30 plus 30 is 0. So this time in the end, we get 0 equals 0. Anytime you have something like this, where the two numbers are the same, the answer is going to be infinitely many solutions. So, with 0 equals negative 12, it's no solution. Or 0 equals any other number, or 4 equals 5, 6 equals 7. So any two numbers that aren't actually equal in the end will be no solution. If the two numbers are the same, that is infinitely many solutions. And those are our two special cases with systems. Okay, 5. So these are going to be our word problems. And we're going to start with this one right here. So John has 13 coins in his pocket, consisting of dimes and nickels only. In total, he has 95 cents in his pocket. So we're going to define our variables. So D for dimes and N for nickels. Now we want a total of 13 in his pocket. So it'll be D plus N equals 13, because we know that the number of dimes plus the number of nickels is 13 coins in total. So that's the first equation we have. Now the second, he has 95 cents in his pocket. For this, we need to know how much a dime is worth and how much a nickel is worth. So a dime is 10 cents, which is 0.10. And a nickel is 5 cents, so that would be 0.05. With nickels, make sure you're not putting 0.5 because that would represent 0.50, so 50 cents. And nickels are not worth 50 cents. So now our second equation, we're going to put how much each dime costs, so that's going to be 10.10. And that's times D for dime. Then plus each nickel cost 5 cents, so 0.05 times N. And then the total cost that he has is right here, so that will all equal 0.95. And this would be our system of equations. Alright, 5b. Jack and Mary are starting a baseball card collection. Together they have a total of 18 cards, and Mary has 3 less than twice as many cards as Jack. So our variables here are going to be J for Jack and M for Mary. And we need to write an equation here. So the first and easiest one is the total sentence. So they have a total of 18 cards, which means Jack plus Mary together, if you add them together, they have a total of 18 cards. Now for the second one, the easiest way to think about it for me is we need to figure out who has more to start off. So Mary has 3 less than twice as many cards as Jack. So that means Mary almost has twice as many cards as Jack. So Mary has more here. And what I like to do is whoever has more, that's going to be the variable that I'm going to put by itself. So since Mary has more cards, I'm going to do M equals. So if Jack had more, I would do J equals. Whoever has more, I like to make that the variable that's by itself. Then Mary has 3 less than twice as many cards as Jack. So this twice is more important. So twice would be 2 times the amount Jack has, so 2J. But then we're going to take this amount, but we need 3 less than that. So 3 less would be minus 3. And these two equations here are the system for this word problem. Okay, 6a and 6b are super easy. So all we have to do, they graph the lines for us, and we just need to figure out what the solution is. So with 6a, the solution is where these two lines meet. So right here, the x value comes first, and that's 3. So I'm going to put 3 first. Then my y value is down here. It's -2. That comes second. Make sure you get these in the right order. So x first, then y. So 3, -2 is where these two lines intersect, which is our solution. 6b, we're going to do the same thing. They intersect right here. Our x value is at -1, and our y value is at +1. So -1, 1 is our solution. 7 says draw a sketch of a graph with no solution. So a line with a graph, two lines with no solution. If they don't have a solution, that means they're never going to touch each other. So a graph with no solution would have to look like this. So these two lines are parallel, and remember, parallel lines, that means they have no solution because parallel lines will never touch. So I'm going to erase this, but one thing I want you to be careful with, I'm going to show you some things that you may get confused about. These two lines right here look like they don't touch. But notice there's arrows on the end, so they're going to keep going. So off of this graph, I'm going to draw dotted to show what would happen. So you see if these kept going, it may not show you the whole graph, but if they kept going, they would eventually touch. So anytime that they could eventually touch, that means they have a solution. It may not be actually shown on the graph, but if you think that, extend your line, see if they would touch, and if they would, they have a solution. So again, I'm just going to draw the no solution. It's going to be some parallel lines. And remember, parallel lines have the same slope. So any lines with the same slope are parallel and have no solution. So if they have the same slope, that means they have no solution. Now there is one exception to that, because this next one says draw a sketch of a graph with infinite solutions. So what infinite solutions looks like, say this is our first line here. What infinite solutions looks like is another line that is the exact same. So I know it's kind of hard to see on a graph because they're both the same line, but say that the equation of our blue line was y equals x plus 0. So just y equals x. Well, the purple line is also y equals x plus 0. So notice these have the same slope, but they also have the same intercept because they're the exact same lines. So anytime they're the exact same line, they have infinite solutions. So I'll just write exact same lines have infinite solutions. So parallel lines, so different intercepts, same slope, no solution. Exact same lines is infinite solutions. Okay, 8. Oops. 8 wants us to write and solve the system. So first we're going to write it. It says a test has 20 questions worth 100 points. The test consists of true-false questions worth 3 points each and multiple choice worth 11 points each. How many multiple choice are on the test? So what we're going to do is we're going to solve this. We need our variables first though. So I'm going to pick t, so a lowercase t. This will represent true and false questions. Then our other one is multiple choice, so that would be m equals multiple choice. So your first step is always just define your variables so we know what you're trying to have them represent. And this tells us right here, the test has 20 questions. So with 20 questions, it's going to be t, so the number of true and false, plus the number of multiple choice m, equals, and then that's going to be 20. So in all, adding the types of questions together, that gives you 20. Now it tells us that the test is worth 100 points. So right here, 100 points. And we know that true and false are worth 3 points each. So that's going to be 3 times every true or false question. So 3 times t, plus 11 points for every multiple choice. So 11m. And then in all, this test is worth 100 points. So equals 100. Now if we look here, this problem is set up for elimination because t's are lined up, m's are lined up, equal signs are lined up, and the numbers are lined up. So what we have to do is figure out what can cancel out here. Now if we look, we have a 3t, so we need this top one to be a negative 3t. So to turn this 1t into a negative 3t, we're going to multiply everything by a negative 3. So negative 3 times 1t is negative 3t. Negative 3 times m is negative 3m. Negative 3 times 20 equals negative 60. And this bottom one will be unchanged, so I'm just going to rewrite it. Now that we have opposites with negative 3t and positive 3t, we're going to add them together. So negative 3t plus positive 3t is 0. Negative 3m plus 11m will be 8m. Negative 60 plus 100 is 40. This 0 doesn't matter, so we just have to divide by an 8, which means m equals 5. So that means there are 5 multiple choice questions on this test. That technically answers this question here, but we're going to plug it back in to figure out how many true or false questions there would be on the test. So I can pick any of the equations. I'm going to pick this one before we changed it. So I'm just going to take t plus m equals 20. And again, we know that there's 5 multiple choice questions, so we can replace that m with a 5. So t plus 5 equals 20. And if we subtract 5, so the number of multiple choice, we get that there are t equals 15, or there are 15 true or false questions. And both of these make sense within the problem. If you ever got like a negative here, you can't have the negative number of questions, so that would be where you went wrong. You'd have to go back and check your work. Okay, 8b. Your sister and you go to Arby's for lunch. A sandwich costs twice as much as a drink. You can buy 3 sandwiches and 2 drinks for $16. What are the costs of each? So here we have 2 variables. It's going to be S for sandwich and D for drink. So this first line says a sandwich costs twice as much as a drink. So again, with my rule, I like to pick whichever one costs more. So sandwich costs twice as much. So sandwich costs more. That would be S equals. Then twice as much as a drink would be 2 times D. Now this next line, we can buy 3 sandwiches and 2 drinks for $16. So that's 3S plus 2D, so 3 sandwiches plus 2 drinks equals $16 total. And this right here is our system of equations, but now we have to solve it. So this one is set up for substitution instead of elimination. And I'm going to box this in. So S equals 2D. And since it's S equals, I replace the S in this equation. So I'll have 3. Instead of S, I have 2D plus 2D equals 16. Then I multiply these out, so 3 times 2 is 6D plus 2D equals 16. 6 plus 2 is 8D. And then to solve that, we divide by an 8, which means D equals 2. So we could buy drinks cost $2 here. That's what that means. Now to figure out how much sandwiches cost, we're going to take one of these equations. So I'll take S equals 2D. So S equals, and I'm going to replace D with 2. So 2 times 2, which means S equals 4. So a sandwich costs $4 and a drink costs $2. So this is the system it wanted written, and this is the solve. (9a) says, given the system, 8x plus y equals negative 16, negative 3x plus y equals negative 5. If x equals negative 1, what is the y value of the solution? So this one is really easy because it does all the hard work for you and it gives you one of your answers. So we get to skip all the steps of finding our first variable, and we're just going to do the plug it in step by itself. So I can pick either one of these equations. I'm going to take 8x plus y equals negative 16. If you pick the other one, you'll get the same answer. And it tells us right here that x equals negative 1. So I'm just going to replace x in this equation with a negative 1. Now we just solve for y. So 8 times negative 1 is negative 8. So we have negative 8 plus y equals negative 16. Then I add 8 to both sides. So I get y equals negative 16 plus 8 is negative 8. So that would be our answer there. 9b is going to be the same type of thing. So it gives us our x value is 9. And all I have to do is pick one of these equations to plug it back in. So this time I'll pick the second one. So x minus 3y equals negative 6. We know that x equals 9, so I'll replace this x with a 9. So 9 minus 3y equals negative 6. Then I just subtract 9 from both sides. So negative 3y equals negative 15. Then I divide by a negative 3. So y equals positive 5. And that's our answer. Okay, 10. So 10a says graph the system of inequalities. So all we're going to do, we're going to take this one line at a time. I'm going to start with y is greater than negative x minus 2. So I'm going to do this one in this orange. So my intercept on this top line is a negative 2. That's where I'm going to put my first point. Then my slope, it's negative x, so that's the same thing as negative 1. So down 1, right 1. Down 1, right 1. Or up 1, left 1. So this first step is just like graphing any other line. Now if you notice here, we have an inequality, and these two will be a dotted line. But if it has that equal to line underneath it, it's a solid line. This first one does not have that equal to line, so I'm going to make a dotted line connecting these points. Just like that. Now, its y is greater than, so anytime this inequality is facing your y, it's greater than, so it's going to be shaded above. Greater than means it's shaded above. And remember, you want to shade lightly here so you can go ahead and graph the second point. Now I'm going to switch to purple. For the second one, my intercept is at +2. And my slope is -5, so down 5, right 1. Down 5, right 1, so we can't go anymore. But again, this one doesn't have this line underneath it, the equal to line, so it's going to be a dotted line connecting these points. Just like this. But this one is y is less than, so I'm going to shade below this line. So everywhere below this line I'm going to shade. And if you're unsure about what's above or below, you can always use your test point and see if it includes it or not. Now what we care about is where it overlaps. So in this case, I'm going to care about where the purple and the orange overlap. So I'm going to take yellow here, and I'm just going to shade this in for the part we actually care about. So where these two lines, the shaded areas overlap, we're going to make that darker. So right here, the yellow is our solution set. This over here with just orange doesn't matter. This over here with just purple doesn't matter. Now, this bottom says circle the points that represent solutions. So I'm going to start with 0, 0. So right here. And 0, 0 is in that yellow area, so 0, 0 would be a solution. 2, 3 is right here. Notice that's only in the orange. It has to be in both the orange and the purple, which is yellow here. So 2, 3, not a solution. -1, -1. Okay, with -1, -1, it is on a dotted line. And remember, dotted line means it's not a solution. So -1, -1, not a solution. If that was a solid line, it would be a solution. And -3, 2. That is clearly in the yellow area, so it is a solution. 10b is going to be the same thing. So I'm going to do this first one in blue. Our intercept for the first one is a +2. And we have a slope of 1/2. So that's up 1, right 2. And we just graph our points like normal. Or we can go down 1, left 2. Now if we look at this sign, it does have that equal to line underneath it. So this one will be a solid line. And its y is less than, which means we shade below. Next one I'm going to do in purple. Our intercept is at -3. And our slope is -2, which means down 2, right 1, or up 2, left 1. This one does not have the equal to line underneath, so it'll be a dotted line. and its y is less than, so I'm going to shade below. And again, we only care about this overlapping area right here. So this is only purple, we don't care. This is only blue, we don't care. So if you have a multiple choice question, it's not going to show these areas that are only shaded for one. So what I'm going to do is go ahead and just erase them. And I didn't mean to erase the whole blue line, but let's put that back in. That was the solid line. So if you have to match in a multiple choice question, it will look like this. It won't have all this other shaded area, even though it was there. And we're going to figure out which points are solutions. So 0, 4. Notice that's not in any of the shaded area, so 0, 4 is not a solution. 2, 0. Not any of the solution set, so no. -3, 0. Now this one is on a solid line. That is why this one is a solution. -4, 0 is just outside, not a solution. So -3, 0 is the only solution listed here. Anything in this area right here would be a solution. And our last ones, we have 10A and 10B. So we're going to start with 10A. Our first step, this problem looks like it's a lot, but if we take it one step at a time, it's not that hard. So first step here, I'm going to graph all of these equations. And I'm going to do each of these in a different color to make it easier to see. So equation A, I'm going to do in blue. This one is at -7 as our intercept. So 1, 2, 3, 4, 5, 6, 7. Okay. And then our slope is -1/2. So down 1, right 2. Or up 1, left 2. This is just a normal line, so we're going to connect it with a solid line. No more inequalities here. So that's our first line. Now second, it's going to be y equals 3. I'm going to do it in green. Whenever it's y equals, that is a horizontal line. So we're going to go to where y equals 3, which is right here. And it's y equals, so that's a horizontal line or a 0 slope. So I'll just draw a line like this. For C, I'll do it in red. So this is another y equals. This time it's at y equals 5. So 1, 2, 3, 4, 5. And I'll just have another horizontal line. And last we have x equals -3. That one will be purple. So x equals -3 is vertical. Any x equals is a vertical line. So this time I'll go to where x is -3, which is right here. And I'm just going to draw a vertical line at that point. Now we're going to figure out which of these statements is true. So one says equation A and D have no solution. So A and D, that would be our blue line and our purple line. So blue and purple, they do have a solution. It's right there. So 1 is not true. Number 2 says equation D, which is purple, and the y-axis have no solution. So purple line is right here. This one is our y-axis. Notice these two are parallel, and parallel lines have no solution. So 2 is one of our answers here. Number 3 says B and C are parallel. So B and C, that's our green and our red. These two lines are parallel, so 3 is an answer. Equations A and D, so blue and purple, have infinite solutions. If Remember from earlier, infinite solutions is when they're the exact same line. So blue and purple, those are not the exact same line, so 4 cannot be the answer. So 2 and 3 are the true statements here. Last one, 10B is almost the exact same. So again, I'm going to graph these same colors as before. First one, intercept is at -6. And our slope is -1/2, so down 1, right 2. Or up 1, left 2. And draw the line. Now our second one is y equals 6. So again, y equals is horizontal, so I'll go up to 6. And I'm going to draw a horizontal line at that point. For the red one, or equation C, we have y equals 7, so that's 1 up from it. Still horizontal though, because it's y equals. And last, we have x equals -4. That's a vertical line at -4, so 1, 2, 3, 4. And a vertical line. And then again, we're just going to look and mark any out that are not correct. So A and D have no solution. So A and D, that's purple and blue. Again, those have a solution. It's right there. So not number 1. D and the y-axis have no solution. So D is right here, the purple one. Y-axis is right there. Those are parallel to each other, which means they have no solution. So 2 is correct. B and C are parallel, so that's green and red. Those are parallel. They both have a 0 slope. So 3 is correct. Last one, A and D have infinite solutions. So blue and purple, those are not the same line, which means 4 cannot be true. So 2 and 3 is the solution there. And that is the whole review.